What's up, everybody? It is still me, Tural, and welcome to our next tutorial related to mastering C# internals. And we are going to talk about C# records. And in this tutorial, I will try to cover everything you need to master C# records. We'll talk about a lot of interesting stuff like non-destructive mutation, special type of construction, deconstruction process, IEquatable interface implementation, method overrides, and etc. We have tons of information for this tutorial. Stick around, let's get started. To learn everything in practice, we just need a simple console application. Now I have tutorial record playground, a branch in our Git repository. I will add the link below the video to check the source code. Okay, and this is a simple console application, and let's create our record and try to understand what's going behind the scenes. Okay, so we'll use the record keyword here, and I will have special record called account. For my account, I just need account number with account name. Okay, cool. Let's just build our application, and I just want to understand what's going behind the scenes, what compiler will generate for us as a source code. Just want to mention that there is no special keyword like record. There is a class, but no record behind the scenes, because records are just a syntactical sugar over your classes. Okay, that's how it looks like. So this is our record. Our record consists from a class with built-in functionalities. So in our case, we'll have a class that has overridden toString method, special type of construction, deconstruction mechanism, non-destructive mutation, and IEquatable interface implementation that we are going to learn everything right now in this tutorial. Okay, now let's go to our project, and I just want to disassemble our application. So I will use JetBrains.py. Let's just open our folder. I'm just going to copy my folder, bin, debug, .NET 8. Let's copy the path and just open file, open. And let's open our DLL file here, okay? In our DLL file, we have mastering records and we have account. This is our record, but let's see what's going behind the scenes. Let's open our account, and you see we have record account, but behind the scenes, we have a lot of stuff here. We have a class. So you see, this is not a record, but with built-in functionalities, with already defined functionalities. So when to use records? You should use records when you want to have immutable object that behaves like a value type. Okay, so you need to use records for your value type based objects. We are actively using this type of records when we build domain-driven design-based applications, especially. Okay, now we have this type of implementation. Let's try to understand one by one, and let's try to write everything from scratch. Cool. Now, what I want to do, I'm just going to instantiate my account and to see what is immutability here. This is my, let's say, account number with my account name, Mr. Name, just name. Okay, cool. And if you want to change some properties from your record, it is not possible because, as you can see, this is get init. It means you can only get data from this property, and also you are able to set values to this property only in a construction process. Let's do the same operation for your class and try to understand everything in more detail. C account, it is my class account. Okay, I will just do the same operation here, try to simulate the record, because record is just a wrapper over my classes, so it means everything should work. This is our primary constructor, but seems something is wrong here. Okay, let's just see. We have account number, account name, but as you can see, they are unread. It means we just need a property here, public string our account number, get init, and assign it to the account number. Same is applicable for our account name. So as you can see, when you type like this one is approximately similar to this one. So the purpose here is to write as least code as possible when you write things using record keyword. Okay, cool. Let's try to simulate it. C account. Let's instantiate our C account with the same values. There is no need to define the class name construction process like this. Everything is okay. And cool. C account dot account number, get init, and for the account name, we have get init mechanism here. They are approximately similar, but that's not, of course, all. We have tons of the things behind the scenes, and let's one by one dive into details. This is our construction process, but records also by default support the construction process. Let's go for it. In our source code, you can see we have backing fields here for our properties like account number, account name, and they are get and init. This is for our previous demo. And for the current demo, we have the construction process. What actually the construction process is, this is the opposite operation for your construction. You are able to construct an object using different properties, and you are able to deconstruct your complex data if you want to extract some value from the complex object. Let's do it. Var, I just want to extract account number, but not account name, and let's provide our account. Means now I have account number. This is approximately similar to account number equal to get from account number. Okay, this is our deconstruction process. So for our records, we already have built-in deconstruction mechanism, and I want just check if we have same possibility for our classes. Of course we don't have, because we haven't implemented the construction process here. So let's say it is account 2, and this is our C account. As you can see, we don't have deconstruction mechanism, so let's try to implement it. Public void deconstruct. And for the deconstruction process, we will use string out string. Okay, and let's get the data for account number and account name. For the account number, I will simply use this account number. For the account name, I will use this account name. And let's just type it to the console write line, account number 2. This account number 2 is going to be our deconstructed value. Let's just run it. So something is wrong here. Okay, let's just add it, and that's all. So you see, we are able to deconstruct our class. So that's how records helps us to not to write the same sort of code every time for all your classes. Okay, so records are just wrappers over your classes that consist from multiple operations in our case. Cool. What else? We have construction, deconstruction process. They are completely okay. Now it means when you have get init, it means this is going to be immutable object. It is not possible to change its value after construction. But if you want to have a different value for your account, you are able to do it using non-destructive mutation. Okay, let's do it for my account. Let's say I want to have the second account here, account 2. Their values will be approximately same, but with a different account name. So I have possibility to do it using with keyword here. So account number is equal to a different account number. It means I will get the same account data with modified account number. It means account 2's the account name will be equal to account's account name. Okay, let's console write line account 2 dot account name. It will be same as our account's account name. So you see they are completely same. Okay, and for the account name account name to account number will get 111. Okay, let's run it and see. Yes, we are getting this value here. So this with keyword here works only with records. This is non-destructive mutation here, and I just want to simulate the same operation for my class here. Okay, let's create C account account 1 equal to C account with account number equal to 11111. So you see, when we have some error here, and it indicates that C account is not a valid record type and is not a struct type. So you are able to use with for your records and with your struct and not for your classes. This is also a built-in mechanism for your records to modify, but this is not a simple modification. This is getting a new object with a modified data related to the previous data. Okay, cool. Now we have talked about non-destructive mutation. Great. Now let's talk about the important thing here, and it is our IEquatable interface. All our records by default implement IEquatable interface. Let's first understand what is the value of having IEquatable interface in your records. Okay, so in my case, I will have this. Let's just remove all this code here. I will have this same sort of account here, and I just want to compare them if my account is equal to account 2, and also I want to compare it using not just equality but also equals method here. And this is our account 2. Great. Let's see what we will get. Of course, we will get true for both situation. Let's run it. And you see they are completely equal. This is a completely different behavior like your classes, because in your classes you have referential equals mechanism and etc. For your records, they are immutable value-based object. It means if all the values are equal inside your records, they are acceptable as a equal object. Okay? So in my case, we have this type of equality and they are completely equal. So how we are able to get the same type of behavior in our classes? This is, of course, really simple. You just need to implement IEquatable interface here. For our IEquatable, we have only one method here, and this is our equals method. Okay. So this is our nullable account. I just need, sorry, this should be the C account. Okay, this is our C account. And I just need to check return the other is not null and others account name is equal to current object's account name and others account number is equal to current object's account number. Okay, I guess this is completely okay. Let's do a bit formatting here. Let's zoom. And yes, this is our equality. And what we need to do here also, of course, we need to override a lot of stuff here. One of them is going to be our equals method. Okay, for this equals, I will use this equals and our object we'll call our equals method, but for equals to work properly, we need to override our get hash code. Let's override it. Override get hash code. I will just use hash code combine this account name, account number. I think that should be okay. I will not override the equality operator here. Just let's check our equals method if it is working for our C account or not. I'm just going to do the same stuff here for our C account. And this is going to be C account 2. And let's compare them if they are equal. Of course, this one will not work because we haven't explicitly defined this equality, but let's check it. So let's run. This should return false, but on the other hand, this should return true. Let's run it and wait. Voila, the first one is false, the second one is true. Why? Of course, we also need to override our equality mechanism here. So public static boolean x operator quality, and for the operator here, I just need to define C account first, C account second. Okay. And you can see this is requiring a matching operator. This requires also override to not equality mechanism here. But let's first try to implement this equality here. And let's copy, paste it here. Not equals. They are not equal like this. Okay. So this is our equality. Let's run them. And voila, we have true mechanism here. Of course, you should be careful when you override these mechanisms. This is not a complete better implementation, but for our purpose, this is just okay to override like this. Okay, don't use it as a dogma. This is just simple implementation. Great. Now we have equality. We talked about IEquatable interface here, and let's move forward. Let's see what we have here. So you see we have special mechanism here, clone. This is for our with for non-destructive mutation here because we need to copy. You can approximately implement the same stuff for your classes, but without with keyword here. So you see, we have equals method for our records. We have virtual equals method here, and we have get hash code method here. And of course, let's talk about toString method. Okay. Let's just console out our C account and just account. And let's see what we will get. Let me remove these comments here. Let's run. For the records, we'll have really great toString definition. So you see, this is some sort of JSON-based mechanism. So it is really easy for you to debug, to log this type of object. There is no need to override toString for your records. But for our classes, we need to implement it. What I'm going to do, I'm just going to copy this mechanism from here and put it to our class to see what we can do with this override. So toString will use string builder. This is compiler-based generation, so this is not a completely better implementation. So it will use the string builder. It is going to build our class. This is going to our C account, and rest of the things should work. Okay, let me just run it. So I will get approximately same stuff here. Let's continue. And here we are. So this is our C account. C account is our class, and this is our record. So you see how we are doing the toString override for our class. So just try to understand that. You see, we wrote a lot of stuff for our class. I don't know how many lines it is, 50, 55 lines we added to our class, but you can do the same stuff just writing this simple line here. So you see, records are just wrappers, decorators over your classes that consist from multiple built-in mechanisms like non-destructive mutation, IEquatable interface implementation, special type of construction, deconstruction, etc. Well, is that all? Of course, not for your records. You can, of course, do additional stuff directly in your record without changing your construction mechanism here. So if you want, you can just override the properties here. For example, I want to set it as a, let's say, protected string account, get set, or at the public, let's do it public with, of course, account number. Okay, and let's go to our account, and for the account number, now I have get set mechanism here. So records helps you to not just modify like this. For example, it is possible for me to set any value now, but also you can add additional properties, account ID, for example, get init. It is also completely okay to have properties directly in your record, not defined in your construction process. Records were added in C# 9 and 10th version, so it is possible for you to not to wrap your classes, but also wrap your structs using records. So in my case, when you type record account, it is going to be a wrapper over your classes, but it is also possible to define record struct account. Okay, when you just type record account, it is similar to record class account. By the way, this syntax is also acceptable, so you can type record class if you in your application you have struct type of records, class type of records. To differentiate them for easily readability, you can just define record class or record struct here. What about our struct records? You should use struct records if you want to provide some domain meaning for your primitive types, okay? You can write wrapper over your integers, your strings, your GUIDs to provide some sort of domain meaning, value object meaning for your primitive types. Let's do it together. So in my case, I will have record struct, and I want to add a wrapper over my GUID to have ID based strong type. So let's call it ID and GUID value. That's actually all. But when you construct this ID, you will realize that we have two issues here. One is we have two constructors, one for default. As you know, for structs, we have default constructor. We should eliminate it. And also the other one for the value itself. But unfortunately, this value is get and set. Of course, you can just add read-only keyword here. So in this case, guess what? Value is going to be get init rather than get set. But let's continue without this read-only, okay? And what I want to do, I want to completely eliminate default constructor. For that reason, I'm going to provide public GUID value. It is going to be get init. As you know, we are able to change the property directly without read-only. You are able to add the read-only mechanism for your value like this, because we are able to change property that defined in our default constructor here. But I also want to eliminate our default constructor. To eliminate our default constructor, we have only one way, let's say one better way. We can just throw an exception when we are calling our default constructor here. So I'm just going to do if our GUID is empty, then I will throw the argument exception, don't call default constructor, let's say. Don't call default construct. Otherwise, I will just set the value. And for the default constructor, I am going to call my main constructor here, and I am going to provide empty value. Okay? Let's do it like this. And guess what? I'm just going to call my ID without value, and it will call this constructor, and it should throw exception because I am providing GUID empty, and it should throw exception. Let's run it, and voila, we are throwing exception here. So we are using these type of structs when we develop domain-driven design-based applications, when we have wrapper over our primitive values like strongly typed IDs. Strongly, for example, you can build your non-negative integers, non-negative short values. You can add additional validation mechanism for your strings to make them strongly typed, etc. So we have a lot of interesting places where we are able to use our records with struct keyword. Well, that's pretty much all about our current tutorial. We tried to cover everything, almost everything related to records. I hope you learned a lot of interesting stuff, and starting from today, you will be able to use records in your practice. If you like my videos, please don't forget to subscribe, hit like button, share, and I will see you in the next tutorials. Bye.